Now that we've taken some time to learn how to do the four-step process for performing a two-proportion hypothesis test, I thought it would be a good idea to take a moment and reflect on some of the differences and similarities between two-proportion hypothesis tests and one-proportion hypothesis tests. So looking at the prepare step for both the one and two proportion hypothesis tests, we see that they are very similar. For example, they both have the identification of the parameter of interest, they both have you list hypotheses, they both have you identify the significance level. The difference comes in for the two proportion prepare step when we need to identify the sample proportion and sample size values for both of the samples that we are considering. And then we use these sample proportions to compute the point estimate. For the one proportion prepare step, the sample proportion is the point estimate, and so that's a big difference between the two of them. Moving on to the check step for both the one and two proportion hypothesis tests, we see here again there is quite a bit of similarity. For both of those, we're going to verify conditions to ensure that there is normality under the null hypothesis. However, for the one proportion case, we're ensuring normality of the sampling distribution of sample proportions. And for the two proportion case, we are ensuring normality of the sampling distribution of sample differences of sample proportions. So that's a difference. The biggest difference, however, is shown in the note down below. For the one proportion case for checking the conditions, we use the null hypothesis value p subscript 0 for all formula work throughout, whereas for the two proportion case, we use what is called the pooled proportion value for all formula work throughout. And that's when the null hypothesis is the difference of population proportions equaling 0. So continuing to look at the check step for one and two proportion hypothesis tests, the first condition that we check for both of them is the independence condition. Although for the two proportion check, we call it independence extended because it differs from the one proportion case in that we are now considering two sets of data. And so we have to make sure that our statement includes that fact when we write that. Otherwise, the independence condition statements are very, very similar to one another. So the last condition we need to look at for the one and two proportion hypothesis test check step is the success failure condition. There's only one thing I want to point out about the difference between the two. For the one proportion case, we use the null hypothesis value p subscript 0 for all calculations of the success failure condition. However, for the two proportion case, we have to be careful because we need to use the p hat pooled value in place of the population parameter p when the null hypothesis is that the difference of the population proportions equals 0. That's a big difference, and we need to be on the lookout for that. Next, let's compare and contrast the one proportion and two proportion hypothesis test calculate step. And we notice in this particular case, we're going to do exactly the same thing for both of those types of hypothesis tests. In other words, if the conditions hold from the check step, we will compute the standard error, compute the capital Z score, the test statistic, and we will identify the P or probability value. So again, in comparing the one proportion and two proportion hypothesis test calculate steps, we look at the difference between how we calculate the standard error. And we notice that the formulas for both are very, very similar. The only difference really is that the two proportion case takes into account the fact that there are two populations under consideration. So that's why we see the extension of the formula that would be used for the one proportion case when we get to the two proportion case. I want to point out one key difference between calculations of these two standard errors. First of all, for the one proportion case, we use the null proportion value in place of the population proportion. And for the two proportion case, we use the pooled sample proportion value in place of both population proportion values, P1 and P2. And that's a big difference again. The next thing we notice in comparing and contrasting the one proportion and two proportion calculate step is that The formula for finding the test statistic, capital Z, is exactly the same for both, and the method for finding the p, or probability value, is exactly the same for both also, in that we use the Arguru continuous distributions probability calculator. So in comparing and contrasting the two types of hypothesis tests for the calculate step, we have one last difference I want to point out, and that's the way in which we label the variable axis that's included on the sketch. So for a one proportion case, it's labeled as p hat. For a two proportion case, the variable axis is labeled as the difference of sample proportions p1 hat minus p2 hat. Before I move on past this slide, it's worth pointing out that the conclude portion for the difference of two proportions hypothesis test is quite different from that of a single sample proportion confidence interval. We're interested, especially in medical studies, in seeing whether differences in proportions can be reasonably explained by chance, that is, when we fail to reject the null hypothesis, versus being explained by a particular drug, for example. And with that closing comment, that's the end of this particular presentation.